Welcome. I'm going to be demonstrating the Electrophorus experiment using an aluminum pie tin, styrofoam plate, styrofoam cup, and you'll also need one of these neon bulbs. It's good to have wool or a cloth of some kind that you can rub the styrofoam with, some Scotch tape, and perhaps a rubber balloon. Alright, so the first thing to do is assemble the Electrophorus, and we'll just use the Scotch tape for that. We want to get an insulating cup in contact with our aluminum pie tin so that we don't have to touch it with our hands. So we'll just tape that. And then it's ready to go. Okay, now we want to be able to place our pie tin on top of the styrofoam plate. So first, let's go ahead and charge up our plate. And we just want to rub it here with wool or cloth. A lot of materials can work well for this. Now, we can see if it's been charged using our neon indicator bulb. So what happens here is if there's a transfer of electrons through the bulb, you'll see it. It's going to flash orange. And so I'm going to put the lights off here. Let me turn all the lights off. Hold on. Now, if I just drag the bulb across the plate, we should see just a little bit of glow. Let me try to charge it up again. Okay. Oh yeah, there it goes. All right. So what happened here is I put excess electrons on the foam plate by rubbing it. The foam took electrons off of the cloth and the foam became negatively charged. And those electrons are just stuck there on the surface of this plate because it's an insulator. They can't escape very easily. But if I give them a path, through the bulb to my body, they'll take it because they want to get away from each other. All right, so let's charge it up once again. Now this time what I'm going to do is I'm going to put my Electrophorus on top of the surface of the plate. Okay. And it may seem like a lot of electrons are going to jump off the plate onto the tin. But the plate's actually very uneven as a surface, and the electrons are not mobile, not very mobile. So we don't usually see a lot of that unless you rub the tin a lot and make a lot of contact. So we're going to assume that the electrons are just going to stay on that foam plate for now. Okay, but what they will do is generate an electric field, and that's going to cause the charges in our pie tin to polarize. So the pie tin should be neutral, and if it's not neutral, you can go over to the sink and just touch it against the faucet here, and that should provide a good pathway for grounding the tin. So hopefully it'd be pretty neutral right now. But in case we weren't sure whether it was neutral or not, we can test that. So I'm going to use the Scotch tape to test it. All right, so first thing, we want to put one tape down on the table. And let's see, I want you to be able to see this. Okay. Alright, so I've got one base tape down. That's just to provide a surface for my next two tapes. It keeps the experiment consistent so that the surface that we're doing it on doesn't interfere. But basically what I want to do is I want to put another tape on top of my base tape, right? So I fold over the corner so that I can pick it off easily. All right, we're just gonna press one on top of the other. It's got a nice handle that I can just grab and yank it off if I want to. Next, I'm actually gonna put one more tape on top of that one. All right. Now I'm going to label my tapes. So the first tape I put down was the base. I'm not going to really do anything with that tape. Okay. Let me give you a close-up here. Okay. So that's the base. Okay, then the next one is a bottom tape. That bottom tape is going to end up being charged negatively. So I'm just going to put a minus on that one. And then my top tape, I'm going to put a plus on that one. All right, next thing to do would be to pull them up from the bottom tape so that I'll have two in my hand at once here. Okay. And, well, you want to make sure they're stuck together well. Just really press them. Okay, great. Looks good. You can try to take any charge off of them and put it on yourself. Now they should be neutral. Okay, fairly neutral. I'm just going to rip them apart as vigorously as I can without letting them touch each other. All right, so these tapes are charged now. Oop. Ooh. Let's hang the positive tape here so we can use it later. I better hang them on opposite sides of this thing. They're very attracted to each other. Okay, great. All right, so positive tape is on the left here, negative tape on the right. Perfect. Now, how do we know whether an object is charged or not? Well, I said that I had rubbed this styrofoam plate, and I said that I had put electrons on it. If I put electrons on it, it's going to be negatively charged, right? So negatives repel negatives. So I'm going to bring this plate near the different tapes. See what happens. Is a tape attracted or repelled, right? All right, it looks like the positive tape is reacting pretty strongly. It's pretty attracted to it. Now let's try the negative tape. Ooh. Oh, not you. Okay. Okay, there we go. Yeah, So the negative tape appears to be repelled by the plate. All right, so that gives us some evidence that there is negative charge on this plate. If you believe me that the bottom tape truly is negative, but maybe you don't. So we have one classic material where we know what the charge of it is. So rubber, when rubbed, will acquire a negative charge. Alright, so let's rub this rubber. Hear the static. Yeah, okay. So I say that this rubber is now negatively charged. If that's true, then it should attract the positive tape and repel the bottom tape. Okay, yeah, it's clearly attracting the positive. No question about that. And let's try the negative. Yeah, the negative doesn't like it. Okay. Great, good to know. All right, so we've got negative charge on the balloon, we've got negative charge on the plate, and let's see what our foil pan is then. Okay, now I say that the foil pan is neutral because I just rubbed it against the faucet there, and the faucet is connected to the earth. Yeah, that should have neutralized it. Let's see. If I bring my neutral Electrophorus toward the different tapes, what will happen? Well, if it was positively or negatively charged, it would attract only one of them, right? So let's see how they respond. Okay, so the positive tape is somewhat attracted to it. Definitely not repelled. Let's try the negative tape. Also attracted. All right, so that's good evidence that this is fairly neutral right now. All right, so what I'm going to do is I'm going to set the Electrophorus back on my plate. All right. Now, I'm going to grab my neon bulb in one hand, turn off the lights, and let's touch the pie tin. Whew! Pretty strong exchange of electrons there. So what happened was, electrons in the pie tin are free to move because it's a conductor. And so the electrons in the pie tin don't want to be near the electrons in the foam plate. So they're going to do everything they can to escape. And before I touch it with the bulb, they will accumulate around the edges because they don't want to be near the electrons in the plate, and they also don't want to be near each other. All right, once I gave them a path to jump off, they did. They jumped to me. And I can touch it again and show that nothing happens anymore. Why? Because the electrons that wanted to get off already got off. So now, in order to put the electrons back, what I want to do is take the plate off of my Electrophorus. But it doesn't want to come off, does it? Why not? Well, because the plate is negatively charged. I allowed electrons to jump off the pie tin. And so now the pi 10 is left positively charged. I'm going to pull the plate off, okay? Now, in order to verify what I said, and if this aluminum pi 10 truly is positively charged, it should repel the positive tape and attract the negative tape. Let's see if it's true. Okay, the positive is just slightly repelled. You can barely see it, but yeah, it doesn't really want to come near the pi 10. We'll try the negative tape. Yeah. Oh yeah. Ooh. Okay. All right, so we've got a positively charged pi 10 now. So what I should be able to do is to come back with my neon bulb, and I'm going to allow electrons a path to jump back onto the pi 10. The pi 10 will attract electrons because it's positively charged. I'll turn off the light and see if it works. Oh yeah. The pi 10 has returned to the state that it wants to be in, which would be neutral. So just touching it now, nothing more is going to happen. So I'm going to set it down. Okay. Back on the plate. Now remember, it is neutral at this time. But now the tin is in the electric field of those negatives on the plate again. So it's going to polarize again. And the electrons are going to want to jump off it. So I'll give them a path to jump off here. I'll try to zoom in. Maybe you can even see the side of the bulb that lights up here. Okay. It was the side closest to the tin, right? All right, now I could touch it again, but nothing's happening. All right, now I'll lift it up. Strong attraction there. Okay, let's see if we can see the other side of the bulb light up this time. All right, so down here, left side lights up here, the right side. All right, now let's try another interesting thing. I set it down on the plate and I raise it up, so it's neutral now. Even though I let the tin contact the plate, all that happens when it contacts the plate is the metal polarizes, but it stays neutral. Some electrons can jump off the foam to the tin, but not really a lot, not a significant amount, unless you really rub it. So I'm just going to lift it up with it being neutral now. If I touch it, not much should happen, if anything. Try it one more time. I set it down. I lift it up. Try not to rub it, and then I touch it with the bulb. Nothing happens. Okay, try it one more time. Touch it with the bulb. No lighting. Okay. It's because it stays neutral the whole time. Okay. Now if I set it down now and touch, now we get that jumping of electrons. All right, so One other thing we can try with this, if you have trouble getting the results that are expected here, is you can actually flip the styrofoam plate. Now the electrons really don't have a path to jump off the plate onto the tin, you know? All right, so now if we set the tin down on the plate, we're still going to get that strong electric field through our tin. The electrons are on the bottom side of the foam plate. They are still going to exert a strong field, causing our metal to polarize. So if I bring the neon bulb near it, turn the light off, we can still observe the effect. Okay, then we lift it, touch it. Okay, the electrons jump back. All right, now we can set it down. And we'll let the electrons jump off. You could touch again, and all the electrons that wanted to leave left. All right, so we can raise it up. I'll touch while the tin is in the air. You can see it start to light up even before I touch it. Yep, there it goes. Okay, now, if I set the tin down, lift it up, touch, and there really shouldn't be much at all coming through the bulb. Okay, because it's neutral. It's neutral when it's in the air. It's neutral when it's on the plate. And we just don't see anything. But if we leave it on the plate, now it's polarized. Electrons want to get off. And there they go. All right. Hope you enjoyed my Electrophorus demonstration. And we will see you next time.